Today we're going to look at what are called active cursors and their use for taking measurements both online and offline. Setting up for online, I'm going to the sampling configuration and then to the channels tab. I see that I already have a waveform channel at 100 Hz sample rate. If I edit this by double-clicking, I can add a title and correct the sample rate for my blood pressure channel to 1000 Hz. Adding a comment, changing the units, possibly a scale, and finally an offset. Press OK, and now run now. A new data document opens, and now we can press Start, and we are recording data. Now I'm cheating and using the playwave function to send data out of the 41 and back in. You may find this useful too if your colleague won't lend you a vein. I've pulled back the thumb that you can see moving at the bottom of the screen. This allows me to review the data and take some rudimentary measurements. I use Ctrl and Alt together and the left mouse click button to produce the measurements. What I'm looking for is the amplitude to determine what a peak is and the times between peaks. Dragging the thumb all the way to the right allows me to continue to see the new incoming data. Up to the measurements icon now, and we're going to go to Data Channel. This produces a dialog that allows us to set the X and Y measurements to be taken. Once a target or destination channel has been selected, we can choose between channel types. Here I'm choosing Event because I simply want a marker whenever we find a peak. You notice that on the right-hand side we now have a grayed out section. This is because with event type data we only have one value to plot, in this case time. We now have to define how our iterator, cursor 0, steps through the file. I'm choosing peak find with an amplitude of 25 mm of mercury on channel 1. We can specify the minimum step or ignore period after detection and also the maximum width of the peak. Clicking New produces a further dialog and a new channel M1. We can specify a refresh rate in terms of the update section and also leeway for processing. Leeway is a time period for other cursors to find their positions as well. Now you can see new markers appearing in channel M1 indicating the times of the peaks which have been found. Right-clicking on the new channel, I choose channel M1, then duplicate, then right-clicking on the new duplicate to channel draw mode. A list of display options are available to us. I'm choosing instantaneous frequency, which is 1 over the interval. The channel now possesses a y-axis. With the use of Ctrl and Q, we can optimize the visible range. The y-axis is in Hertz, and if we change to per minute and draw, we convert to beats per minute. Changing now from instantaneous frequency to mean frequency, we have an extra item which is time. As we change the display from 1 to 5 seconds and press draw, you can see that the output becomes much smoother. Reverting to offline mode now, I'm looking at blood pressure waveform, which you should have in your Spike2 data folder. Now you can see that this data is a little noisy, so this may cause problems with some of the feature detection. So I'm going to use channel process, then smooth, to take out some of the small deviations from the true waveform. Right-clicking on the waveform, channel process, and then add smooth to our channel process list. And you can see that the waveform has changed. This data is good enough anyway, so I'm going to clear the processes and take some offline measurements. I'm now going to add cursor 0. This is the iterator. Without it, no other cursors are able to move automatically. Right-clicking on the cursor gives me active mode, and then a choice of the type of search method. The other settings that we see in this dialog are exactly the same as we saw in the measured to channel dialog. Again, the amplitude value of 25 will describe the rise up to and fall away from the main peak. We can test the success of the cursor using Ctrl and Shift and right arrow key. Now let's produce cursor 1 with Ctrl and 1 and set its active mode to be exactly the same peak find. This time we have a start and end of the search range, so I'm setting 10 seconds in advance of cursor 0. Testing again, and we can see that the cursors move correctly. With our pulse wave now bracketed, I'm going to use cursor 2 to find the minimum value between the two cursors. This time we can illustrate a backwards search. So from cursor 1, looking backwards through to cursor 0. Slightest movement of cursor 0 updates all of the other cursors. Adding cursor 3 with Ctrl and 3, I'm going to ask it to find the second peak. This time, we can set a smaller search range from cursor 0 to the lowest point in the pulse wave, cursor 2. We can also set a smaller amplitude of 5 mm of mercury. Once again, we can move cursor 0 to update all other cursors. Now let's perform the measurements. This time, instead of data channel, I'm going to use XY view. The dialog we see here is very similar to that we used for the measured channel, except that we can plot more than one channel to the result XY view. We can ask to check the user positions for each measurement, an X measurement and a Y measurement. These measurements include taking single values of waveforms at a given time point through to time differences between cursors. Time difference allows us to set a reference time and the time to measure to. For convenience and for a later XY view legend, we can title the channel. Here I'm calling it beat to beat. We could process this one channel, but let's add another. Once again, we can title it systole this time. We can choose value at point and specify the time and the channel to take the measurement from. We could change the X measurement for this channel independently of all others, but let's add a third channel, labeling it diastole, selecting time at point on the X measurement, but this time the X is the cursor 2 position, and for the Y, I want the value at cursor 2. If we need to edit any of the channel settings, we can go back through the list and change any of the parameters we wish. Pressing New, we have the option to set the time range of the data file to analyze. Process, and there we have it. Our XY view, 3 channels of measurements, and now we can color them. At this point, we might want to tile the windows. So Window, Tile vertically, and there we have it. Up until now, we've seen our cursors labeled as 1, 2, 3, etc. Here, by right-clicking on a cursor, we can set our own label. Here, cursor 0, user-defined label mode, and systole. The label can be dragged, and we can set further cursors as well. So that is it. Analysis of blood pressure using active cursors both on and offline.